everybody. We are going to be learning something brand new today, and it's all about isotopes and how we should write about them. We're going to start by reviewing stuff we already know that's like ancient history. We learned about atomic number and atomic mass and how they're two different things. So I'm going to draw for you part of the periodic table. Which one of these numbers is the atomic mass? You're right if you said atomic mass is on the bottom. And what is carbon's atomic number? Yes, its atomic number is 6. And what does that tell us? It has 6 what? Yes, our atomic number tells us the number of protons. Carbon has 6 protons. Atomic mass has a unit to it. So when we write about carbon and we say its atomic mass is 12.01, its atomic mass is 12.01 atomic mass units. How do you get to that final number? You add up the protons plus the neutrons. So, for example, carbon is 6 protons and 6 neutrons most of the time, more on that later. And when you add that up, you get 12 atomic mass units. Make sure you put AMU on the end of this stuff. Sometimes you're not going to know the number of neutrons, and we're going to have to find it ourselves. We can do that with just a one-step equation. It's kind of like algebra. Imagine if I told you 12 equals 6 plus x, and I asked you what's the value of 6? Sorry, what's the value of x? You would say x equals 6. It's the same logic here. Your atomic mass is equal to the number of protons plus neutrons. So let's check out oxygen. I'll draw you the atomic symbol, oxygen. Its atomic number is 8. And what does that tell us? Yes, oxygen has 8 protons. Its atomic mass is about 16 atomic mass units. So AMU, or atomic mass, equals what plus what? Yes, protons plus neutrons, and now we're going to substitute. Our equation is going to look like 16 equals 8 protons plus neutrons, and we don't know how many. So we need to do just a tiny bit of algebra and say 16 minus 8 equals neutrons. 16 minus 8 is 8. There are 8 neutrons. That type of math is going to work perfectly every single time. I want to take a second and do that with the element gold because it is more complicated and we'll double check that we really know things. So let's go to the periodic table and find some information about gold. Gold's atomic symbol is AU, and I need to find it. Here it is. Its atomic mass is about 197, and its atomic number is 79. So we're working with the numbers 197 and 79, and this is gold. How many protons does gold have? You're right if you said 79. So its atomic mass of 197 equals 79 protons plus a number of neutrons that we don't know. Try it on your own. How many neutrons does an atom of gold have? You got it if you said 197 minus 79 equals 118 neutrons. We did it the same way as oxygen, it's just bigger numbers this time. All right, now I'm going to blow your mind and start talking about isotopes. First, I'm going to show you how to write them. You can write them as element and then the atomic number, like carbon 12, or the atomic number like a superscript and then the element, like little 12, carbon. So here's some examples. Normal carbon. This is just a normal atom of carbon. It has 6 protons and 6 neutrons, so its total atomic mass is 12. So we have the same thing here. Both of these mean carbon with an atomic mass of 12. But here's something new and different. Hold on. Okay, as we were saying, so isotopes are basically freaky alternate universe versions of atoms. So carbon-13 is an isotope. Let's see what's different about it. It still has 6 protons. That's what makes it carbon. But check this guy out. He's got an extra neutron. So his atomic mass equals protons plus neutrons. And in this case, his atomic mass then equals 6 protons and 7 neutrons, and that's going to give us 13. Whoa, that's why it's called carbon-13, because its atomic mass is 13. We can write it like this or like that. They both mean the same thing. Let's get even weirder. Welcome to carbon-14. It's awfully similar. It just has 1 extra neutron, and that's why its atomic mass is 1 higher than carbon-13. If I tell you I have carbon and it has an atomic mass of 14, you now know everything you need to know, because you know atomic mass equals protons plus neutrons. And you know that no matter what, carbon has to have 6 protons. That cannot change. It stays carbon. It stays atomic number 6. Its atomic mass is changing. So its total atomic mass of 14 equals protons plus neutrons. And that's how you find the number of neutrons. 14 minus 6 is 8 neutrons. Isotopes are atoms that just differ in the number of neutrons. Everything else about them is the same. They just might have a lighter or a heavier nucleus. So let's try some examples. For each of these three, we're going to decide how many neutrons this atom has. It might be an isotope, it might not. I will start with the first one and I believe that is phosphorus. So it has an atomic number of 15 protons. Okay, so mass equals protons plus neutrons. Just going to write now I'll write the whole thing. And in this case, the mass is 33 atomic mass units. And because it's phosphorus, and I looked it up in the periodic table, it has 15 protons. That's its atomic number. That's never going to change. What can change is the number of neutrons. I'm going to do 33 minus 15 to find the total number of neutrons, and my final answer is 18 neutrons. Now you guys are going to do a little more work for nitrogen 15 down here. I will look up for you what is the atomic, actually you look it up, what's the atomic number of nitrogen? If you went to ptable.com, you discovered that nitrogen's atomic number is 7. So it has 7 protons. How would you set up your equation? You got it if you said the mass of 15 equals 7 protons plus, I don't know, neutrons, but we don't know how many. To get our final answer, 15 minus 7 protons equals 8 neutrons. And that is your final answer. Go ahead and try number 3 all on your own. Okay, let's check it. We're dealing with lithium this time. So what's the atomic number of lithium? Let's look it up. Lithium is atomic number 3, so it has 3 protons. Now let's go back to our notebook and write that down. There's 3 protons in lithium. So our equation is going to look like mass of 7 equals 3 protons plus some number of neutrons that we don't know. We can get to a total of 7. 7 minus 3 equals 4 neutrons. Our final answer is that there are 4 neutrons. So now I want to tell you why this entire time in chemistry class, the atomic masses in the periodic table have been freaky decimals. It's because of isotopes. So here is sodium. Its atomic number is always 11. What does that mean? Yes, it has 11 protons. But the atomic mass can actually change because it might have varying numbers of what? It might have varying numbers of neutrons. So when we take this atomic mass, the way that we get to this number is we take the average weight of all of the isotopes of sodium, and we average them together to get that best estimate that's near 23. So this average mass is the sum of all the naturally occurring isotopes, so ones that exist on Earth in a certain amount. Chlorine's atomic mass is usually about 35 atomic mass units. But the real truth is that only 76% of chlorine atoms actually have an atomic mass of 35. The other 25% of chlorine atoms actually are isotopes of chlorine and have a mass of 37. Why are these chlorine atoms heavier? You're right if you said because they're isotopes and they have more neutrons. So, the way that we calculate the average atomic mass for chlorine is we take these facts and do some math with them. So when we do this math, what we are saying is that the mass of 35 AMUs occurs about 76% of the time. So 76% of our number is going to come from that version of chlorine. Where does the other 24% come from? That other isotope of chlorine that has a mass of 37 atomic mass units. So we got this final number by multiplying mass A times the abundance of A. And then we added it to mass B plus the abundance of B. And we got our final answer of about 35 AMUs. Let's do an example all together. We are going to find boron's average atomic mass. Where could you find this? You could find it in the periodic table, like the periodic table just tells you, but here's how they got to it. They said, here's an isotope of boron with atomic mass 10. And here's an isotope of boron with atomic mass 11. What percent of boron has an atomic mass of 10? About 20%. So we're going to multiply 10 by 0.199. And now, what percent of all the boron on Earth has atomic mass 11? 80%. So we're going to multiply the mass 11 by 0.801. So here's the math we're doing. First, 10 times 0.199, that's going to give us 1.99 plus 11 times 0.801 gives us 8.811. Add those two bad boys together and you have your final answer. About 10.8 or 10.801. Both of those answers are totally fine. So all we did was take the two isotopes and multiply them by their abundances. We added them together and we got our average atomic mass. So this is the number that would go under the B for boron on the periodic table. So we would put that number right there. Okay, we're going to do another big scary word problem together and just buckle up. The final question is, how many protons does this element have? So we need the atomic number. We don't know it. We don't know what this element is. It's just an element. So what we need to do is some detective work. We have a mystery element, we have a mystery atomic number, but we can find the atomic mass. So we're going to find the number that goes on the bottom over here, the average atomic mass, and that will help us find the element in the periodic table. So this is what we're finding right now, and it's going to help us identify this element. So let's find the average atomic mass. It equals isotope 1 times its percent abundance plus isotope 2 times its percent abundance plus isotope 3, if it exists, times its percent abundance. So here we go. It tells us that 24.1% of all the isotopes of an element have a mass of 75.23 AMU. It just gave us this first part of the equation. So isotope 1 has a mass of 75.23, and we multiply it by its percent abundance. What am I going to multiply it by? You're right if you picked 0.241, because that's how percents work. Now what about this next part? What am I going to put? The problem says 48.7% of this isotope have a mass of 74.61. So here's isotope 2 of the same element, and we have these numbers. So we're going to write mass 74.61 times its abundance. What am I going to put in parentheses? 0.487. We just have one more isotope to fill in, and then we'll just be plugging it in our calculators. Our third isotope, what's its mass? Yes, its mass is an AMU. So we're going to write 75.2 times its abundance, which is 0.272. So now we are just going to put this in our calculator step by step. Go ahead on your own, put this in your calculator, and tell me what you get. We got the same answer if you came out with 18.13. I know there's some other stuff after that, but we can estimate a little bit. Nothing terrible will happen. Now you're putting this part in your calculator. Try that out and tell me what you get. I got 36.34. And the last part, try it out in your calculator. There's our final answer, 20.45. All right, Now let's add all these together and remember what we're finding. We're finding the atomic mass so that we can identify the element. Let's add them all together. 18.13 plus 36.34 plus 20.45. Our answer comes out as 74.92 atomic mass units. All right, now come to the periodic table with me and we'll find which element has that mass, approximately. We're looking for a mass of about 74.92, and you found it if you clicked on arsenic. Check it out. It has a mass of 74.92. We just calculated that. And how many protons does it have? It has 33 protons. So that's our final answer to the original question. How many protons does this element have? It has 33 protons. How do we know that? We calculated its average atomic mass, and we looked it up in P table. And we found out that we were talking about arsenic the whole time. And how many protons does arsenic have? 33. What a wild ride. This is just showing you the math written out, but in better handwriting, so you don't need to look at that unless you want to. I am here to answer anything, and I would highly recommend when you're doing your virtual notebook, you look at the answer key video. It is so helpful. I'll see you later. Bye.